Okay, guys, so we have been solving systems of linear equations, and so far I've given you two different methods. I've given you graphing, okay, where you take both equations, you graph them, and then you determine the solution by finding the point at which the two lines intersect, okay? Um, I've also given you one algebraic way where you don't have to graph, but it's referred to as the substitution method. So with any algebraic method, okay, including the substitution method and the one we learned today, the idea is that you need to somehow combine the two equations that have two variables. And when you combine them, you end up eliminating one of the variables and are left with one equation with one variable. Okay. And then that is going to allow you to solve. So with the substitution method, we substituted one of the equations into the other. Okay. And in doing so, we were left with one equation with one variable. Today, we're going to look at another algebraic method, okay? Um, and so our motivation will be the same. We want to somehow combine these two, both of your equations, okay? And when you combine them, the idea is that you need to end up with one equation with only one type of variable, okay? So the elimination is a method used for solving systems by adding or subtracting the equations. Okay, by adding or subtracting the equation. So what I'm going to do is I'm going to combine them, okay? And then when I do that, one of the variables, I'm going to do it in a way to make sure that one of my variables disappears, okay? All right, so step one, since we're adding or subtracting, remember back from math lab, when you add and subtract, you have to make sure your numbers line up, right? You had to make sure your decimals lined up. You had to make sure your denominators lined up with fractions. You had to make sure a whole lot. When you add and subtract, you have to be very particular. You can only add and subtract things that are the same. So that's the same here. I need to make sure everything's lined up because in algebra, we know we can only add or subtract like terms, all right? Now, step two, I'm going to either add or subtract the equations to eliminate the variable with a common coefficient. Let's remember what what a coefficient is. A coefficient is a number that comes in front of your variable, okay? The number that comes in front of your variable. Okay, and then once we do this step, this is the step that right here, this is where you end up with one variable, one equation with one variable, okay? So that's the kicker. Now, guys, everything else from here is gonna be the exact same as a substitution method. Once you have one equation with one variable, you solve for the remaining variable, okay? And then after you're done solving, you need to substitute your answer into the original equation and solve again, okay? So you said everything from here on, these last two steps, those are the same exact steps as the substitution method, okay? So we really just got these first two that are gonna be, we'll say, new in this technique. All right, let's look at number one. So I have y equals 3x plus 4 and y equals x minus 2. So they're going to give these to you in a way today where you're always going to have one of the variables having a common coefficient, okay? So if you remember an equation, so let me just take this equation for example. In an equation, you can add whatever you want to this equation as long as whatever you do to one side, whatever you add to one side, you add to the other. Same with subtraction. You can subtract something from one side of the equation, okay, as long as you subtract it from the other. So if I wanted to subtract 4, or let's say 12 from this side, I can subtract 12 as long as I can subtract 12 from that side. So when we do this, though, we're not going to subtract just a single number, okay? What we're going to subtract is a whole equation. So let's take this blue equation, or this equation, this blue one right here. And what I'm going to do is I'm going to subtract it. So I'm going to subtract the y from this side. Now, instead of subtracting a y from this side too, all I'm going to do is, since y is the exact same thing as x minus 2, that's what I'm going to subtract, okay? I'm not only going to subtract the y, I'm going to subtract the x minus 2. Okay, that way what I'm doing is I'm subtracting the same thing from both sides. Even though y and x minus 2 don't look alike, this equation tells me that they're exactly the same. Okay. Okay, so I am going to back this up because this is looking a little messy to be able to start this equation. But, okay. I'm looking at my equations, and step 1 says to make sure everything lines up. The y's are lined up, the x's are lined up, and the constants are lined up, okay? And more importantly, the equal signs are lined up. So everything's lined up, good. We don't have to do anything in step 1. Step 2, okay, we're going to find in these examples that a pair of your variables already have common coefficients, okay? Now, looking at the x's, the x has a 3 and this x has an imaginary 1, right? An invisible 1. So those aren't the same, okay? But here, the y's, they both have a common coefficient. That coefficient is 1. So let's see if we can combine these equations in a way that those y's will disappear, okay? So we need to either add or subtract these equations together. Well, let's think if we add. If we add, we'll have 1y plus 1y. That's 2y. Those y's didn't go away. What if we subtract? 1y minus 1y? Yeah, that equals 0 y's. So in short, just 0. Your y's went away. That's awesome. So now let's go ahead and keep subtracting. 3x minus 1x. You get 2 x's. Now be really careful with this. And some people even kind of rewrite this, but I have a positive 4 minus a negative 2. If you have a positive 4 minus a negative 2, that's the same thing as saying 4 plus 2, right? So don't forget, if you have 2 minus signs, that will give you a positive 6. Some people do like to do this when they know they're going to subtract. They'll write each equation off to the side, and we'll do this, and then distribute that negative sign first before they subtract. So they would say negative y equals negative x plus 2. And then they would just combine them together, okay? All right. So now we have one equation with one variable, so we can solve. So when you solve, you want to get the x all by itself. So the first thing I'm going to do is eliminate this this constant over here by subtracting 6 from both sides. Okay. And then I have a negative 6 equals 2x. And then I'm going to divide by 2. And I'm going to have x equals negative 3. Okay, so this is the same as before. Now you have an option which equation, which original equation you want to plug it into. It does not matter. Okay, you can plug it into the first one or the second one. Try and pick one you think that might be easier. I'm going to pick the second one only because it looks like that one's a little bit easier to work with. But if you pick the top one, that's okay. So if I can find out what y is if I know what x is, but I do know what x is, right? X is negative 3. Okay, so I have negative 3 minus 2 is a negative 5. And those are my solutions. Remember, solutions, if you plug them into these equations, both of those equations will be true. If you graph these equations, this would be the point negative 3, negative 5 would be the point at which they intersect. So keep in mind, after you find your answers in math, always review what you just did, okay? And what does that mean? Okay, I'm going to work out some more in the next video.